everyone to Auto Stamps Free webinar. My name is Joe Hammond. I'm sure many of you already know me. I've been in the industry for over 22 years, providing automated software products and services. Auto Stamped is continue this tradition by offering products such as ANSYS, Cimatron, and tool planners. We're also known as the assist companies as extension of their engineering departments. Our mission is to seamlessly integrate the design and engineering process with the metal forming manufacturing process. Today, we are excited to welcome Jeff Bennett. He's a a founder of the president of Tool Planners. Jeff is a developer and a die estimator, and his innovative products and services for die cost estimating. His area of expertise includes die shop management, cost estimating, and tool and automation design. Tool Planners serves on the metal stamping industry with software training and consulting and services for die estimating. Jeff is a regular speaker at the PMA seminars and has served on the PMA's technical task force. And I want to welcome Jeff Bennett. Jeff, are you there?
I am here, Joe.
Wonderful.
Turn my camera on here now. Okay, welcome everyone. Thank you for coming to this morning's webinar, and we will get right into the content. And let me share my screen with everyone. Joe, are you still there?
Yes, I am. I do see your screen. I see it. Actually, it's a black screen right now.
Yeah, I'm trying to get this to respond. My apologies. I'm going to rejoin the meet. There you go. I was about to rejoin the meeting.
There we go. Good.
All right, perfect. Can you see it? Okay, Joe.
Yes, you are live and ready to go.
All right, great. All right, let's go back up here to the beginning. All right. So this morning we're going to be talking about die cost estimating, and got a brief PowerPoint presentation I'll start out with, and then we'll actually go in and estimate a part. We'll talk about how to use the applications. So let's get right into it. So we're going to look at objectives of any die cost estimating system and what are the current industry challenges that we're facing. Next, we'll look at kind of what's out there, current die estimating methods that are in use today, and then look at some new technologies that have come along that may change the whole die cost estimating paradigm. Next, we'll look at how to build confidence in your die estimates. Then we'll look at a checklist for if you're considering a change in the way you estimate dies, some things you should be looking for. And then we'll look at the return. If you do go down this road, what can you expect in the way of return on investment? And lastly, will be the example estimate that we'll do in Die Estimator. Okay, a good die estimating solution should be configurable and capable of quoting any die using consistent methods to produce successful quotes while simultaneously reducing the internal cost of quoting. So that's a mouthful, but basically the goal here is to win more profitable jobs at a lower cost. So there are two types of die estimators in the industry. There are those who build dies and those who buy dies. Builder, and they have separate needs and requirements, and they're both facing challenges. So let's look at the die estimator column first. Die builders, particularly die shops, do an enormous amount of quoting. Our typical client will quote in the neighborhood of 1,000 dies per year just to stay in business. Now that can range from on the low side to 300 to 500, and we've seen as high as 3,000 to 6,000. So it's an enormous amount of quoting. And the reason, part of the reason there's so much quoting is that there's very low closure rates typically. The the jobs that are won from quotes typically are less than 5%. We see as low as 1%. We see as high as 20%. The 20% typically is a captive shop.
I'm sorry, you're cutting in and out, Jeff.
So we all know what happens as a shop. Okay, thank you, Joe. All right, I'm spinning right now. Can you hear me, Joe?
Yes.
Okay. All right. Did you hear the part about, let's see, I was on eras in process and price. Did that come through okay, Joe?
Let's repeat that.
Okay. All right. So one of the challenges for a die estimator or die builder is, uh, eras in their processing and pricing. And what typically happens is if you make a mistake, a lot of times you'll get that job and it could result in a losing job. The next is high cost of sales and estimating. So in order to do these 1,000 or so die estimates per year, you have to have engineers, you have to have salespeople, and it takes a lot of their time to produce the estimates. And then one thing that we hear a lot is finding and retaining qualified estimators. So the workforce is aging. A lot of the qualified die cost estimators are retiring. And so a lot of companies are faced with replacing that talent. And how do you do that without losing what the experienced estimator has in his mind and train the younger or the newcomers? So that's die builders. That's just a few of the challenges that they face. On the buyer side, um, these are companies that are getting quotes from the die builders, and they see large die quote variations. Plus or minus 50% in price swings is not unusual. They're having to wait on quotes in some cases 1 to 2 weeks, depending on their relationship with the die shop. And that leads us into dependence on tool shops. So before a stamper can quote the production part, uh, they typically quote tooling and production, and they've got to get those tooling costs from somewhere. If they're not doing it internally, they've got to depend on the die builder to do it, and that can take some time. So these are just a few of the challenges that are facing the industry. Let's look at some of the current methods that are out there. First is, and the one that takes the most time and really is impractical for the way the industry works, is the detailed design, bill of material, and operations method. So that's a mouthful, but what it basically means is I have to design the die before I can quote it. And of course, we all know in our industry, we have to quote the job before we get a purchase order and before we can actually design the die. So this first method is if you
Jeff, we're losing you.
notice here. Oh man, I apologize. I'm not sure exactly
So
why, Joe.
we just
I'm
went off
if
about just 20 seconds. So if you want to just back that up 20 seconds and continue, I think we'll be
okay.
fine.
If that continues, I'm going to re-enter the meeting. Okay.
Fair enough. Thank you.
All right. So as I was saying, it's a speed versus accuracy dilemma, and some of these methods are fast, but maybe not as accurate, and some are maybe more accurate, but take a considerable amount more time. So the second method here is the historical method. That's where we look at past jobs that we've quoted, try to relate that to a new opportunity. This has problems in that every die, every part is different, and even subtle differences in the part geometry and tolerances and so forth can cause problems with this method. A real popular method is die area or length, basically dollar per inch or dollar per square inch method. This is very fast and it can be workable provided you do very similar type work um, of the same construction specifications and so forth. Once you get out into the ends of the bell curve where it's the parts a little bit different, then this method falls apart as well. And then there's the probably the oldest method, and that's the experience-based estimate. You might call that a guesstimate, and that depends on somebody having. Am I still with you, Joe?
Yes, everything's
Okay, good.
sounds great. Thank you.
All right. The experience-based estimate really depends on someone who's quoted a lot. They can look at a part, they can look at the whole project and put a number on it. And we have even seen cases where you'll get 2 or 3 estimators together. They'll all make a write their quote down on a piece of paper and average. There's all kind of methods out there, but this leads me into the process-based standard cost method. This is where we are. We have striven to be both fast and accurate in providing a lot of detail. And the only way that can be done is with a standard cost system that is highly automated. And you'll see that a little bit later as we get into the application. But this really gives you everything that you need in order to get your die cost estimates out. Okay, so this leads me into new technologies. Web-based software technologies are now available that produce consistent, detailed cost estimates quickly with less reliance on highly experienced estimators. The results of this type of technology is that you're able to respond faster to your customer. You can quote quicker. You get much better consistency, almost absolute consistency in your results. And of course, we all know, being in manufacturing, that consistency can lead to accuracy if the system is calibrated. With the amount of data that we're processing, we now have more and better quote detail. When you provide that quote to your customer, you can provide all the information they need, whether they be a OEM or tier 1 or metal stamper, things like die size, tonnage, material usage, and all the information that they need. And then information for your own company too as well, hours, delivery times, and so forth. So much better information is available. We can lower the cost of quoting and sales. We mentioned this earlier. This is really key because of the cost that is incurred by
Cost that's occurred by Jeff. That's kind of where you left off at.
companies, the amount of quoting required. Joe?
Yes. Yeah.
Am I still good?
Yeah. You actually kind of went out a little bit. I think you were mentioning you're probably back up about 10 seconds.
Okay. So I mentioned lower cost of quoting and sales. That's an objective and it's attainable with these technologies. And then increasing closure rates is very important. An incremental increase in the closure rates can drive down the amount of quoting. And I have a slide that'll show that here in a minute. Now, one thing that always comes up, not always, but often comes up, is, are cloud-based solutions secure? Excuse me. Not all. Hey, Joe, is my camera on?
Yes, it is.
All right, let me stop sharing my camera and maybe that'll
Okay.
help the situation. All right. So not all cloud-based applications are secure. They are, though, however, if it is a secure site, HTTP type sites, that the data is encrypted to a high level, both in transit over the internet and while it is stored. This is key, probably the most important one. Servers, and they're secure if the servers are, there's multiple servers, they're hardened sites, and they're redundant. In other words, your data is stored not just in on one physical machine, but multiple machines spread out over multiple geographic areas. And if your data is backed up, and the backups are automatic, they don't depend on an individual to do this. And then finally, and this is an optional, depending on your level of security, multi-factor authorization. And that's basically, we're all familiar with, you try to log into your bank and they send you a text message and you enter your code and then you're off to the races. So this, many technologies have moved and are moving to the cloud. And so this is very important, especially if you're doing work for some of the larger companies that really look very closely at this. So make sure I didn't miss one here. Okay. So confident quoting. How do we get to a quoting system or an estimating system that produces the kind of numbers that we need to run our business? Well, the key to any of these systems is that you include feedback from actual performance into the system. We call it calibration. Basically, if you look at this cycle image to my right here, you estimate the die, you build the die, you report actual cost that was required to either buy or build the die if you're not a builder. Then you compare those actual cost results to your original estimate, and then you make adjustments to your system, and then the cycle continues, and then over time you get as accurate as a result as possible, keeping in mind that we're talking about die estimating and not die design. And that's an important distinction I think that we should make about estimating is, um, not only are estimates not perfect, but neither are job cost. So what you're looking for, the goal here is to achieve a narrow band of accuracy, month in, month out, so that over time you're achieving a few different goals. You're winning your share of work, and you are making money on the jobs that you do. You can get all the work you want by being cheap, but you'll lose money. And if you quote high to be safe, then you won't get enough work, and that will starve the shop. So it's a balancing act, but the way to achieve that is through reporting actual results and making adjustments. All right, so let's look at a checklist here of things that we really should look for when we're looking at changing the way we estimate. And I would dare say everybody on this webinar has some method currently to estimate a die. If it's not been adequate, if you're looking to make a change, keep these items in mind. First of all, is the system capable? It should be able to quote any part type, any die type, and to any construction quality. That the last part of that sentence is very important. If your die estimating system does not consider the options that are in the die, the types of tool steels, things like whether it's your tool steel is inserted or not, or die buttons or not, or whether it's um, nitrogen or coil springs, all those types of options play into the price heavily. And I don't have this in the slide, but the greatest impact on a die cost estimate is first the labor rate that is applied. Your labor rate and profits are number one. And close second is the construction quality of the tool, whether it's a short run die or whether it's a high production die. There's quite a difference. Can be quite a bit of difference in the price. The system should be productive. It should be fast. Typically we're looking for estimates, definitely less than 30 minutes per estimate, down to 5 to 10 minutes per die cost estimate. Our die target product was designed to do die estimates in less than 5 minutes, and we'll look at that here in just a moment. The system should be easy to learn. A lot of systems that are available or that have come out are CAD based. So the first thing you have to do is you have to learn the CAD system before you can quote the die. That can be difficult depending on your experience level. So we're looking for a system that's not only easy to learn but easy to use, has a comfortable user interface, and it's something that you don't have to, to have a reference book beside you while you're trying to use it. So that's really important. It's got to be configurable. If the system cannot be configured to your business, your methods, and your cost, it's not going to generate prices that you're going to be happy with. The system should put out detailed reports that you use both internally and to satisfy your customers' requirements. Number 5, it should provide data. The most popular method is some form of spreadsheet, but the problem with spreadsheets is you have no usable data once you're complete. It's a one-off estimating method. Typically, these are written around our earlier slide, either some rule of thumb method or some approximation type estimating. But getting back to the data portion, if you use a database as opposed to a spreadsheet, then you have all of your estimating history. You can report your actual cost, and you can use that data to produce better estimates. Portability is an issue. You want a solution that's multi-site. If you have facilities in the U.S. and Mexico or Canada and Europe or wherever, ideally you want a multi-site system that can handle all of that diversity, both imperial and metric units, multi-currency, multi-language. All of these come into play if you're more of a global type player in die estimating. It should be, of course, multi-user. Users should be able to. You should have an administrative user that controls what all the other users can do. And then it's ideal if it will run on multiple devices, laptops, desktops, even mobile devices such as tablets and phones. Not that you could actually quote a die on your cell phone, but you can certainly access the data through your cell phone. And of course, that would be mobile, not dependent on a desktop or a hardware key or software key that confines you. Just quoting from the office or quoting at home can be difficult. Training and support, you want to look at that. It's important that you can get the help you need quickly, that you can train quickly, ideally using we use a video method, basically YouTube videos for fast training. But beyond that, having someone who has knowledge of die design and build methods that will not only help you get started, but also support you going forward. So the product, a lot of larger software companies' solutions become pretty static. Once they're launched, you won't see a lot of change or improvement. Your voice is, I don't know if anybody's felt like this, but I certainly do with some companies that, I wish it would do this, but there's nobody there to tell this to. So It's nice to see improvements regularly, and that your voice be heard, so that user feedback makes the product better. And our products have been built on our user base input. And then finally, it needs to be cost effective. Softwares of this type can be pretty expensive, and you want to make sure that you're getting a good return on your investment. Let's look at an example, potential justification here. This is based on the average die shop for the US being about a $5 million a year company. They quote, let's say, is $75,000. So using this scenario right here, and you can do this for any company, but the first thing we want to look at is closure rate. Let's say we're averaging 3%. Let's go down this column first and look at the cost of estimating. In order to maintain this 5 million in sales with a 3% closure rate, I have to quote $167 million worth of dies. If you divide that by the average die price, that's about 2,200 quotes per year. If it takes an hour per quote to do these 2,000 quotes, you're looking at the same number of hours in this case. And if your hourly rate for quoting, that's the cost of your experienced engineering, your sales team, whoever is involved in this, this is a cost to the company of about $260,000, which is a lot of money. And keep in mind that anything we can do to reduce this number will go straight to the bottom line of your balance sheet.
Jeff, are you still there?
I'm here.
Okay, fair enough.
Did I bleep out again, Joe?
Well, I'm not sure. I think you ended, and then there was just a 5-second gap of non-response. So I think you're fine. Everything seems to be working well without your camera work being on. Thank you.
Good. Okay. So yes, and I'll pick up down here. The cost of quoting for this scenario is 25,000 roughly of cost. This is an expense to the company that can be, if reduced, any savings will go right to the bottom line. So how can you increase your closure rates? Well, our experience, and not only do we provide software solutions, but we do consulting as well at Tool Planners. The companies with the highest closure rate are those that are quoting to companies that have the business and somebody's going to get the job, and B, that have a good relationship with the customer, and the customer would like to buy the die from them if they're competitive. These two items are very, very important to increasing closure rate. We see a lot of companies that just quote everything to everybody, and those are typically the ones that are in the very low closure rate category. All right, let's move over here to a scenario where we make a change. So just by increasing our closure rate slightly, we can reduce the amount of quotes needed from 167 million to 100 million. That automatically drops our quotes down to 1,300. Now, if we can at the same time save time on each quote that we produce, let's say we can cut that by half, from an hour to a half hour. Very reasonable to be able to do this. Then our hours spent quoting is dramatic. It goes from 2,200 to 670 roughly of estimates that we have to do, again, to maintain the sales volume that we want. Well, if we are also able to change maybe the way we manage our quoting, we can drop our average hourly rate for the quoting process substantially. And let me tell you how that you can do that. Identify your procedures for quoting and then divide responsibilities between sales, engineering, estimators, and administrative roles. We see a lot of companies where one person is doing everything. Our typical customer will have 1 to maybe 3 estimators, and it really seems to be independent of the size of the company. If we can offload from the highest paid individuals, from the engineers, some administrative duties, and even um, let them do the actual pricing of the die, we can dramatically lower this average rate. So how do you do that? How do you split the engineering from estimating? Well, engineering should be looking at the die process. How are we going to make this part? What type of die are we going to use? Is it a 1 out? Is it a 2 off die? And those kind of decisions. Once the process has been determined with the right software, the estimating process is pretty much a measure and count process. You can close this loop and go back to engineering and say, this is the price that we've generated. They can approve or edit, and then you pass it to an administrator who can then actually produce the quotes and manage the quoting information. So this is something we advise. You don't have to have a lot of staff to do this to see a big drop in hourly rate. So if we take these hours now, they're new hours times our new rate, we can drop our estimating cost dramatically from 270,000 to 50,000 a year, which is a savings of 216,000 for this example. Now everybody's different, and we'll be glad to analyze your site, provided you can provide the numbers. All right, let's look at an example part. This is going to take us into our demonstration of die estimator. And I've picked this is a seating part. We'll call it an automotive customer. We'll call it a bracket. This is an HSLA, excuse me, grade 50 material. Material thickness is 2 millimeters, and the die is to produce 100,000 parts per year. So we'll use this one for an example. Keep in mind that you can do anything from flat parts to
Hey, Jeff, if you're still there, we did get cut off when you were mentioning about we do flat parts.
very, yeah, flat parts.
Yes.
Just
Okay.
oh, that was a question. I'm sorry.
Yeah. No. You kind of cut out. You stopped at as soon as you said this software does flat parts, and then of course we missed the rest of the conversation.
Okay. Yeah, I was saying any type of part or die. So thick, thin, flat, cut and bend, crash forms, drawn parts, small dies for small electrical devices, all the way up to large panel dies for the automotive industry, and both plate and cast construction. So we offer 2 products. The die target is designed, or the die estimator is designed for the die builder. Die target is designed for the die buyer. And here's the main differences. With die estimator, this is a more detailed method. You have full control over all the settings and the cost. It's completely configurable, and you typically set this up for a die shop, or a stamper. If you build your own dies, this would be the solution that you would look toward. Now we came out with a new product last year designed specifically for die buyers. The goal here was to make it extremely fast, very easy to use, and not require a lot of die experience. Basically, with the die target solution, you're describing the part and the process, and you can generate a die estimate. Now, the die target version uses the same engine as the die estimator product. We'll see that here in just a moment. All right, before I get into the the actual demonstration of the product, if you want more information after this webinar, contact Joe Hammer at Auto Stamped, and he will take care of your needs. And so with that, I am going to get out of the presentation and we'll go into Die Estimator. So Die Estimator runs in any browser. I happen to be in Google Chrome, and I've got a tab open here. We supply a URL to access the website. You will have a username and password, and with that, you log in. When you come into Die Estimator, you'll notice this is a very clean user interface, very simple, easy to use. You'll see a list of estimates that you can search and that you can sort according to any of these columns. You will have your user controls up here. Our training videos launch in YouTube. This is about an hour of training in order to become proficient in using Die Estimator. You also have a contact support link here that will launch a form, whether this be a suggestion for an improved help, this will go straight to our support. Apparently having some internet. All right, so here's our list of estimates. Now, we manage the estimate from initial request for quote all the way through to awarded. So you can report cost. This tab typically is what you're working on currently. Once the estimate is complete and ready to be quoted, then it goes to completed. And then the awarded is where you report cost and track the history of your estimating. There's two main areas or two main sections of Die Estimator. There are the estimates, which is where we are right now, and then there are settings. And settings are this is what controls the estimate. Everything from the standard costs that are used, spring costs, tool steels, die construction specifications. These are the settings that are under the control of a die estimator user. Their labor rates, profits, delivery estimates, customer data, and so forth. So that is what is behind what we're going to do. Now we're using a set of standards from our demo site. The software does come preloaded with industry average standards. And I didn't mention that in the earlier video under Die Target, but Die Target uses the if you're benchmarking cost of a tool and you don't have a die shop, then it will use the global standards to produce that. You have some level of control over that, but of course not to the extent that you do in Die Estimator. So let's pick. I created this estimate here simply by creating new estimate. So we'll go into that part. So estimating a die is step one. It's a step fashion working from left to right all the way through the final die estimate. You can both in Die Target and Die Estimator quote the production part if you want. So on the first tab here is your basic request for quote type information. Who are we quoting to? You'll see there, this is my list of imaginary customers here. I'm going to quote to Automotive Inc. I can assign dies to a project. I can create projects and customers on the fly with these links. It will tag the estimate with my estimator login, and then I enter the part name, number, and revision, and select the material type. And I've selected this material right here for this part. I can enter the annual usage for reference and then select from the following die types. Now, die estimator will quote progressive transfer, manual fed line dies, cobot line dies, tandem press tooling, blank dies, and then compound dies. Really any type of die. Moving to the next tab. This open file is where you import your file. So what I did here to get this in is it's asking me if I want to replace that model, and I don't. But this will take you to your file system, and then you can open either IGES or STEP here, and then it's always a good idea, I think, as the estimator to visualize what it is you're making. Now, not only can you work from 3D models, but you can also work from drawings. Many companies still are provided PDF drawings of their part. And in this case, I've just captured a partial part of a PDF drawing and pasted in here. I can either import a PDF drawing directly. If it's a multi-page PDF, all the pages will come in, or I can paste, which this is a handy tool here that I'll show you in the next image that I'm going to bring in. So I'm going to add a page here, and this is what I'm going to use to quote my die. So I have this image over here on my other screen. And so I'm going to use my snipping tool to just grab this image here. And then I'm going to paste that image directly into the die estimator application. Now this nested blank was generated in Autoform Easy Blank, which is a free service provided by Autoform, and this will give us a good blank size. So I have my model. Like have we've already pasted in the drawing. So let's add I've got the nested blank. What if you have for instance, a full strip layout? I'll open this PDF here of the, yeah. So if you've generated this in your design system, you can bring that in and work with that as well. So it's really what you have available at the time of quote. So let's go through and quote this. So I said from my request for quote, I know my material thickness is 2 millimeters. You can enter a formula, you can enter directly into a field, or you can measure. There's 3 ways you can put data into the system. So we know that our blank size is, going over here to this page, my coil width is equal to 114 divided by 25.4. And my left to right, or the step or pitch of the die, is equal to 160 divided by 25.4. And there's my blank size. You notice because this is the progressive die, it set the pitch of the die to be the same as the blank left to right. Now, if you have a transfer die, your station to station pitch could be greater than your blank size. Then I put in the part height. If I want to know about how deep the part is my forming depth. I can measure that. Next, I pick my carrier type. I can add additional material if I want. I can include stretch webs if I want. This one does not require one. And then in the cutting and forming section, we're only going to measure, the cutting and forming that goes onto the die. This is basically a punch schedule. So let's grab this from our flat layout, and I can go around and any of the 2D, anything that's 2D, you'll have to set a scale on. So my scale, let's use the larger dimension of 160 millimeters, and it just go from here to here, and that sets a scale. Very easy to do. Now let's get our blanking length, and I'm just going to go around the if I know the exact size of the cutting, you may get that from either your design system. It actually is provided on the Autoform Easy Blank report, and is with most systems. But so I've got 23 inches of blanking here. This part gets drawn. I can either I can measure that off of any of my tabs. So this area here is going to get drawn. And it calculates my draw area. I could restrike this draw, which I know this is restruck in this, and really it's up to you as the estimator too, how you process the part. We can then pick embosses. Let's go back over here. We notice there's no embosses. I can do large internal openings. I'll treat this as a large internal opening, and I'll just measure this with the circle function. And I've now got that punch in place. Now, one thing that's not obvious about this part is that the it gets trimmed. So it gets trimmed here. I believe I have to set my scale first. I haven't done that yet. So that's 99.5 millimeters. This is my reference dimension here. Now let's measure the trimming that's going to take place in the die. So this gets trimmed from here to here. And then when you go to a different punch, you separate it with the brake button, and then we're going to measure here. So that's my trimming that's going to go on after we draw and restrike the part. You next measure your bends. So we're going to bend this flange right here. I can restrike bends as well. I can do U and wing bends with the double bend function. Let's now count our gussets and dart. I'm having a little bit of lag time here, so I apologize, folks. So I've got 3 gussets, and now let's count our punched holes. We got 3 punched holes. 2 of these are keyed. And so that's pretty much it. I can do extrusions, I can do projections, I can coin and flatten areas. Oh, this part does get coined. So I'm going to go back over here to my it gets coined around these areas. So I'm going to coin here, here, and here. All right, Joe, how are we doing on time?
We're looking good, Jeff.
Okay, great.
I think we got 40 minutes, and I think as you go through this process, I think we'll be able to get through another example.
Okay, well, we may want to save some time for Q&A at the end.
Certainly.
All right. If you have cams in the die, you just measure the cam face width. So I'm not doing this in this part, but if I had a cam across here, it'll measure the cam and it'll add the count. You can do that for both die mount cams, aerial cams, and bumper box cams. And to erase something, you just zero it out. Now, one thing that's very powerful, especially if you're not an experienced die designer, is our die estimating station algorithms. When I click this button here, die estimator will suggest a number of stations to make this part. If you want to look at the detail, you can expand it and you can look at the count for the various types of stations that were suggested. If you wanted to add an idle, you can change that. You can modify these however you wish. If you're going to do, say for instance, you were going to do your hole punch and your internal opening in the same station, I can drop this and add it down here to that station. So I've got some control over the station count. I'm going to update my pilots for a single carrier. Now, if this was a double row carry, I'd have more pilot punches. Now, as far as estimating dimensions, these are the dimensions that are used in your initial sample inspection report that is part of a PPAP process. You don't have to use this part of die estimator, but if you are required to do that and you include that in your tool cost, then there's two ways you can do that. You can either use the algorithm to suggest it, or if I have a drawing available, which I do in this case, I'll go around and I'll pick the critical dimensions. And this works just like a highlighter. So I'm identifying what's critical on this part. And then I can come back and count the non-criticals. Just about everything is critical on this part. And that's tolerance, so that's critical as well. Oh, here's some reference dimensions down here. So we change colors there. So basically changing highlighter color. Okay, so now we've got a little different count based on our actual review of the drawing. You don't always have a drawing, so this you would want to use the algorithm for that. Now, a nice feature that's in here is we are measuring this actually per the process, but if you are measuring just a single part, I can change this value and automatically estimate this as a 2-out die. If I'm measuring the actual strip or process, then I can say it's a 2-out die, but it won't affect the measurements. All right, so this is a 1-up die. We then go to the die specification. This is very important in die cost estimate. We want to pick the construction specification applicable for this die. So this is our customer here is Automotive. We're going to pick their standards and we're going to apply. And what you get is a list of die construction features, and they're broke down by groups for design, punch and die options. I can either accept this die specification as previously written, or I can modify it. If, for instance, I wanted to take adjustable forms and die buttons out, I can do that. Basically, you have control over each individual die, so you can have a unique die specification for every die if you want. Some are drop downs, for instance, spring types, how I retain the stripper and forming pads, and we divide spring pads into strippers, forming pads, and binders in die estimator. Let's say I want to add pin and bushing guiding to my stripper, and I want to include stripper windows. So I'm just making a few changes. You can choose between plate and cast construction, the type of guiding system, whether you want bosses or thrust blocks in the die, the type of buildup. If you're a high-speed stamper, you may have a solid buildup with, your scrap falling through the bolster. We'll go with parallel. You can add mastered change plates. If you have gang dies that are mounted on a common plate, you can pick this. You can select your tool steels, and this list here can be anything you want it to be. This is just how the system comes, but you can add tool steels and you can take away. Most of the lists that you see, or the drop-down list, can be customized over in settings. So these are the tool steels that I'm going to use. This is my die and part approval process for this. This is an automotive company. I'm going to inspect 6 parts, 100%, 30 criticals. I've got 1 part off per die, so there's 1 inspection, and I am going to do a process capability. I'm going to run this off at both the seller and buyer's plant with a 300 piece runoff, and I'm allowing 8 hours for 8 man hours to do that. All right, then we move to calculating the die. We've got enough information now that we can size everything. So we're going to hit the calculate all button. And when we do that, it's going to size the die set, both the top and bottom plate, the number of guides, setup blocks. All of these values on this page are driven by both measurements that have been made and the standards that you have in settings. Things like your plate thicknesses, the number of guides for a particular size of die set. All of this is right here. Your shoe thickness. Those are all controlled in settings. Then I can just review the values. Here's my punch links. Let's say I want to go up to a little bit thicker stripper here. I can change anything that that's shown here. Here's my number of parallels estimated with an average width of 2 inches. There's no master plate. It does estimate your wire EDM path lengths for both your punch. If it suggested wired EDM and you had nothing but like a straight cutoff, you can change these values if you like. And this estimate is also controlled in settings, and it's based on the amount of cutting that goes on in the die. Now this die has some complex shape to it, so it's recommended die surface or punch face machining for 2 punches and dies with a face area of this amount and a depth of cut of this amount. This is used to estimate the complex surface machining. I am going to leave that as is. You can add items to as well if you want to. And then the stock control, that's things like guides and lifters and so forth, was based on the fact that we picked a progressive die. Had we picked a line die or transfer, these would have been different values. So this covers your guide rails, lifters, ejectors, all that type of stuff in the die. If you apply sensors to your die, you can either do it for your customer's requirements or your internal stamping shop, and you can save your sensor packages in settings. And so for this particular die, our standard is a stock buckle at the end of the die and a short feed sensor. If I want to add something, I can just change the value. Now, if you're a metal stamper, you'll put your presses in here. You do that in settings, and you'll see a list of your presses. And so if I select a press for this die that's not big enough, it's gonna flag that I don't have enough tonnage and I don't have enough bed length. So I can go back and repick until I find a press. This one's a little short, might be able to squeeze it in there, but I'm gonna step on up one more time. And this is based on your presses, not on some imaginary press, but once you put in your press parameters, then you can compare the die requirements to the press specification. Now, if you're building this die for another shop or a customer, you're a die builder, and you want to change this shut height and they want something a little bit different, you can enter a custom shut height for this die. Okay, next is custom items. I'm having another little delay here in my internet. Bear with me. All right. So custom items are anything that's not in the normal standards. There is a list provided by Die Estimator that you can pick from, covering a lot of different items. Let's put 4 balance blocks in here. And you notice we've already established what the material and labor cost is for a balance block. We just put in the quantity. There are quite a few here to pick from. You can create your own and save them. If you do transfer dies, you can apply transfer tooling. You can do gauges. You can do literally anything you can imagine here. Ejection cylinders, tapping heads, what have you. You can also add something just for this die. It's completely open here, and you can estimate something unique only to this die. All right. So then we price the die. In this step here, you select the difficulty factor. These are also customizable. And like you may want to create a difficulty factor just for draw dies or just for heavy gauge or light gauge material or whatever. You could do it by customer even. And then you pick your cost estimating standards. You can have multiples of those if you like. I'm going to be this one. And then I'm going to apply a labor rate. If you offshore, you can estimate what the die will cost from wherever you're going to. It may be a low cost country, but let's do this one for an average USA shop. And then I'm going to apply to the labor rate cost a profit of 10% on material and 30% on labor. Once I make those selections, then it builds a bill of material style estimate. Now this estimate, this list is, there's quite a lot here. It's grouped by category for the die, and it rolls up your final estimate here at the end. So let's look at this real quick. We've got die shoe grouping. It will give you the material, the labor, both in hours and cost, and a total for this grouping. Anything that is white here can be modified. So you can modify the amount, you can modify the price if you want. If you modify something, let's say I wanted to go to, I wouldn't, but let's say 2 set blocks. When I make a change, it will lock that value so that if I re-estimate this, it'll always have 2 set blocks. Now I can unlock that, go back to 4, and then keep going. Here's my build-up cost for the parallels. The punch and die selections that we made. Punch and die options. Here's our cutting inserts, buttons, so forth. All of our spring pad cost, both for the springs and for the guiding and retaining of our spring pads. Our stock control, we didn't have any cams here. We took that one out, so that's 0. Here's our sensor cost. Tool steel cost, wire ADM estimate, you know, labor. That surface meeting that these pauses are not related to the software. They are an internet or Teams, I'm not sure which issue. And while I'm on that topic, it does not require a high-speed internet connection. You can do this on as little as 10 megabytes per second connection. Here's my design estimate, tryout, time, part approval process, and die approval process. For this die, your total material is 23,700, labor at 38,000, for a total cost of 61. Then we add profit on top of that to the tune of 2,600 and 16,000. And so my total estimate for this die is $80,681. If you can adjust prices at two levels, both at the customer level or at the overall level. This has no adjustment built into it, so no value is shown. It estimates your delivery based on the hours that are in the job and displays the total hours. So once I'm done with the die estimate, if I want, I can then estimate the part. Most metal stampers have a method for doing this, but if you're a die shop and you're doing short run, or if you want a quick estimate of what this part will cost. Another thing this is useful for too is comparing methods, whether you run transfer or progressive, 1 out or 2 out, you can compare the part cost. So I'm just going to put in some quick numbers here for the cost of the material, for the lot size, how fast I'm going to run this die, how long it's going to take me to set up the tool, the cost of my press with operator. And then I can also look at tool amortization if I want. So if I was going to amortize this over 2 years, that'd be 200,000 parts, and I can generate my part costs both without and with tool amortization. You can see there's substantial difference. So if you're making a decision on how you're going to run this part, if you're using it for that purpose, then you'll be looking at it with tool amortization. So 45-cent part. The report is quite detailed in Die Estimator. So here's my header type information about the part, my sheet material usage, the operation, and die stations that we define for this die. Your die size, including an estimated die weight, tonnage breakdown, cost matrix, cost summary, and hours by function. And then here are the images that I use to quote the die, and I can then export that as a PDF. Joe, why don't you talk to our attendees for about 2 minutes while I step for a quick break, okay?
Yes, fair enough.
All right.
Gentlemen, I guess, is there any questions I can answer for you while Jeff is out?
Hey, Joe, after looking at this, he just finalized this. So he had a strip layout going into the quote. If we don't
Right.
have a strip layout, will this report put out a strip layout based on the information provided?
No, but it will give you the process. So for an
Okay.
example, if Jeff kind of made it alluded to, there's different ways to come up with getting a blank. There's free services on the internet. There are other companies that offer that type of blanking service. And of course, also nesting as well. So ultimately, you kind of want to come in and provide yourself not only the blank, but come up with your progression as well. So that gives you all that's needed to bring into use as a prompt, so that you can walk through the different steps of showing what type of features are actually going to be used on that part, so that it can develop the punching blocks, can develop the piercings. And for each function that Jeff has actually put onto the side indicates what is happening behind it. So, what materials or what functions are needed to make that particular punch or forming block or a coining operation functional. So That's kind of how it's simplified. And if you notice how Jeff kind of walked through the different areas by just once the product's in to calculate what the features that are being recognized within the part, that's how he's coming up with the different sizing of the part file to come up with the final cost of what's needed at the very end. And that's in the target costing. And of course, the die estimator, that's when you can actually go in and start, getting more in detail, giving you kind of a bill of materials behind the scenes. I should say an estimated bill of materials behind the end at the end.
I'm back,
Okay.
Joe.
Yeah. Hey, Jeff.
It sounds like you might have had a question there from someone.
Yeah, absolutely. We
good.
talked a little bit about what is needed to bring into the program, and ultimately, you really don't, other than just needing a file, you can actually bring in the file and take measurements off of that particular file,
Yeah.
so that realistically, there's probably to get more accurate, it's best to have the actual blank itself, but you could still come up with a good estimate without the blank and bring in just solely the file itself.
Now, in that estimate I just did, I used the blank that was generated out of a free service by Autoform. So if you, there's 2 or 3 ways you can do the blank. You can do a section view. If you only have a PDF drawing, that might be the quickest way to come up with a blank estimate. But like Joe says, we do recommend some type of flattening software, ideally. All right, so if it's okay, Joe, I'm going to move to doing that same part, and I'm going to do it really quick using the die target method.
Yeah, I think they'll ultimately give them a better perspective in real life situation. And I realize this is more for the stamper. But again, it does have the ability to go directly into the die estimator.
It
If
will do
need
that.
to be.
We'll
Right.
convert it once I'm done here. We'll convert it over to
Okay.
a die estimator.
This will be perfect
version.
because this will allow us the last 15 minutes to show a quick representation of the speed and accuracy of the
All right.
software. Thank you.
So you can name any of these estimates. If you use quote numbers, you can do that. So let's pick our customer again, put in our part name, go down to the type of part that we're estimating. So let's bring that one back in here. And all we're going to do is just bring in the model. So your question for a model. So we designed this for users who maybe are not as knowledgeable of dies. So we're describing part features. We can define this as a complex with trim because we know we're going to have this complex shape and we're going to trim it afterwards. Pick our material. You can measure the material thickness if you want, if you don't know exactly what it is. We do know this one is 2 millimeters. We can hit a quick detection, which will give us our part depth and an approximate. It'll approximate the cutting, the complex shape, and the trimming. Now I'm going to change this, and I'm going to trim just where I need to. Just trimming right around this corner here, and it's trimmed over here as well. All right, then we'll grab this internal opening with the circle function here. And it's color coded. Red is cutting and green is bending. And we'll catch our darts. And we flattened, I'll use the line function to go around here, flattening in that area. I flatten around this area here and around this one as well. Count our holes. This one was a blanked opening. You can add markings and stamps. I didn't mention that earlier. We then pick our die type. Make sure I've got everything here. I do. All right. Now, it approximated based on a bounding box, the blank size. You can do this different ways. I could do a section, but I'm just going to go with this quick estimate. Now I'm going to estimate my stations. Pretty close. I'm going to pick my construction standards, put in the shut height, select the source for where I want to buy this die, and create the estimate. So in less than 5 minutes, I was able to import a model and quote the die. I didn't do the production part cost estimate, but I could have. The report, if you only purchase die target, this is the report that you'll see. And it's the stamper's report. Not as much detail as the full die estimator, but again, quite a bit of information here so that you know which press to quote for this die, how much material you're going to be using per part, and so forth. So that's the report. You can in both die estimator and in die target CSV. So if I wanted to look at this in Excel, it comes in as an unformatted list of reports. Now, if you have to complete cost detail sheets, or maybe you want to do this for internal purposes, you can use this to drive whatever spreadsheets you want to create. Now, let's say this was round one for this part. I can copy this and convert it to die estimator if I have the die estimator version, and it comes right over with everything already completed for you. So it's the same estimate as before, except for custom items. And there's the report. If I want to go in and do some modification to this, I can. Let's say I wanted to improve the blank size a little bit, change blank size to, say, whatever, actually can review my punch counts here. This all looks good. And then I can re-estimate it. Maybe I want to estimate it from a different source. Let's say I'm outsourcing, and I think the company that I'm going to take this to is maybe a little bit lower cost. I can build that estimate based on that costing parameter. And it should go down, and it did, to 61,000. But that's how die target works. If you once you notice here's our original target estimate. Here's what we actually think we can source it for, and it's all there. I can reopen either one of these if I want. Okay, so Joe, you want to take a few questions for the last 10 minutes?
Yeah, let's do that instead of going through the chat. It seems like we have a bit of time. Is there any questions we can answer for you?
Don't
Hey
be
Joe, I
bashful.
have a question.
Sure.
How do you come up with your low cost country prices, and do you survey around the world and research that?
Yes, we do. What we use a combination of sources for that. We use the Department of Labor. We also use the International Special Machine Tool Association, and basically wherever we can get data to try to estimate what. Once you have the labor cost and the value add for a particular country, you can back into the hourly rate. So it is an estimate. If you have history with a particular source, let's say in China or Taiwan or wherever, and you know what their rate is, by all means use that. But for benchmarking, it's based on global data, and we update that every 6 months. So we're trying to go to quarterly, but right now about every 6 months we revisit that. If you're a die target user, you have some control over settings, but generally speaking, your benchmarks either internal hourly rates or off of the global rates that are provided with die target.
Great
Now,
question.
if you want, we can go in. Let's say you subscribe to die target, we can go in and calibrate you, even though you only see the die target settings, if you provide the data. Now that is an additional service that we offer.
Thank you.
Mm-hmm.
Thank you. Very good question. Is there any questions we can address? We still have 8 minutes on the clock.
Well,
I have a
those
question.
Go
Sure,
ahead.
sure.
Oh, for in the inserting or bringing in your reference material, you're bringing in the 3D file a step, or are you actually clicking on geometry, or is it just visually representative of where you're clicking?
It actually, it's a takeoff method. It is clicking on the model, but it's not actually picking up the CAD data.
Okay. And then second, on that same topic, are you able to bring in a DWG and click on the DWG for dimensions?
You can, but you do that through the cut and paste method. So if I have a any type of file, I can capture the image from the screen and paste it directly into the application.
Okay, so you're not.
And it actually works. It actually works better that way than it does manipulating the CAD file.
Okay, so you're bringing in raster image, not vector image.
On 2D. On 2D we are, yes. Now we do bring in PDF, but not DXF or DWG.
Okay, thank you.
Mm-hmm. Now of course, we have limited time here, but we brought in complete 3D models of an entire 240-inch die, transfer die, and so the images that you can bring into the system are virtually unlimited. Good questions.
Absolutely.
So those two prices you came up with, the 61,281 and the 86,972, both of those have margin on them?
They do if you want it. I'll go to settings here briefly, and I'll go under profit. You can have multiple profit selections. You can bring it in with no profit. You can estimate it with whatever profit you want to create. It depends on your shop. I did one the other day for a shop that was 15%. So,
But with your model that you just did, they both have margin on it? There's a 40% difference in pricing. That's why I asked.
Well, I also changed the country that came from. So,
okay.
But yeah, on the first one I did, it was about 80,000. I think I based that on U.S. average. I know how much that die cost, so it's actually a little low. I think it was sourced for 92. And again, it depends on some of the features you pick. The spec has a lot to do with the price of the die.
Right. Okay.
Mm-hmm. And let me if there's not any other questions, and and by all means, we have time here, but I just wanted to say that Die Estimator was, you know, the background of the company is die builders. We didn't come out of the CAD industry. We came out of the die design and build industry and metal stamping. Myself and others who've worked on this product have quoted a lot of dies. So we understand kind of on both sides, whether you're a die buyer or a die builder, what you have to do to get quotes out quickly, what the accuracy requirements are, and so forth to do that. The calibration of the system is very important. It takes some time. We have instructions on how to do that. What we recommend is you bring in initially 5 jobs that you've already done and use the actual strip layouts and even the actual die designs and quote that die exactly like you built it. Then compare the estimate to the actual and then go in and make the necessary modifications. We can either help you do that or we can give you instructions on how to do that yourself. But for instance, the standards, let's say that these were your company standards and you wanted to modify those standards by a percentage to try to get closer to reality. There are tools in the software to allow you to do that.
So I got
But
a
yeah.
question for
Mhm.
Joe. This is more directed to Joe Hama, I think, in his software. So we currently use the Cost Optimizer Professional
Sure.
for do a lot of our stuff. How does
You know,
this compare to that as far as?
that's a great question because the
That is a good
engine,
question.
yeah, the engine that's ran inside of the Cost Optimizer Professional is the die target.
No, die estimator.
I mean, I'm sorry, the die estimator module. Thanks, Jeff.
Yeah, the
So
database, we provide the database to FTI for them to generate those numbers. And we have an agreement with FTI. There's no non-competes or anything like that. We're both free to do whatever. So we offer this. They have great software. I love their process planner, especially the flattening and nesting. But I think they lack a little bit of control on the tail end of the actual pricing of the die. We do give you that level of control to be able to go down and adjust anything you want. It depending on the type of user you are. There's some users that's adequate. But I will say that you don't necessarily have to have a full strip or full process layout in order to quote a die. If you have a nested blank and a formed part, if you get your stations correct within a station or two, you can generate the same die cost estimate, if not better.
Question. Noticing when you did the estimator and the target, there's a significant difference in die size and material usage.
Okay.
Which resulted in obviously different pricing, but
yep. I had different blank size is what it was. Yeah. The blank size estimate was
blank.
Yes, it is important to have an accurate blank. I won't lie. We would love to integrate flattening into die estimator. That's on our development schedule to do that, but it is not there yet. You will need a third-party flattening application to do that. We point people to Easy Blank because Easy Blank is free. And if the downside to Easy Blank is you have to have an IGES file. But if you can convert your step or whatever into an IGES, then it'll flatten your part for you and it'll nest it and it'll do feasibility on it, which is pretty nice. And again, that is free.
Very comparable to the Fast Blank software from FTI.
Hey, Jeff, can you show us where to add transfer fingers and hardware for transfer dies?
Sure. So let's pick this part right here. Let's say we're going to transfer this one. We'll let you get the model here. This is one we've already done here, but So if I wanted to do this as a transfer over in custom items, I would add a stamp that will.
Hey, Jeff, did we lose you? Oh, there we go.
Yeah, you did. I clicked out again. Can you hear me
Okay.
now,
Yeah,
Joe?
yeah. Thank you.
Yeah. All right. So down here, and I've got these grouped together. I can do this either as like per station. I can do it per die. I can do it for each individual one that I want. And I just add these. So if I'm just going to add a whole group, and see, I've got this identified as per station at $1,000. Let's say I had 6 stations, then it's going to give me $6,000 plus this much labor per 6 times this much labor to apply that. And then when you get to the estimate and I build that, it'll show up in the custom items. I can do gauges there. I can do anything in there that I want to add to the cost of the tool. I'm definitely having internet issues, and I apologize. Very frustrating. Oh, here's why. Let's do it again. Come back into this one. All right, took me a while, but I'm here. There you go. There's my transfer tooling. And this can be as detailed or as simple as you want. Depends on your, you know, how you estimate your transfer tooling. You can do on die transfers. This could be $100,000 HMS system or whatever if you wanted to add that on there. So you can add anything in custom items. That answer your question?
Yeah, that's perfect. Thank you, Jeff.
All right, thank you.
Well, I think we're a little over time. I mean, we can continue to go if Jeff, that meets your schedule,
Sure,
but
that's
I
fine.
think,
If some need to drop off, that's fine, and
Absolutely.
I can hang around for questions, no problem.
yeah. Well, I think we're at the end of our time and end of questions.
Hey, Joe, I
do
got
want-
a question.
Yeah, absolutely.
Can the software be set up to be customer specific? We're a die shop and each of our customers have different standards, of course.
Great question.
Yes.
Yes.
Yeah. Over in settings, under your die specs, you notice here, I've already created some for my imaginary customers. Lawn Products has one, Automotive Inc., and you can have as many of these as you want. It's very easy to create a new one. You just take one that's close. Let's say I want to start with an A-class general spec. I can then go down here and copy that specification, and then I can rename it to and then save that, and it's there. To,
Okay, Jeff, you faded out there, Jeff, but I got the idea. Thank you very much.
yes. Joe, did that all come through okay? Because I heard a little blip in the
Yeah.
Teams meeting.
Yeah, you made your case. I mean, it came through
Okay.
and showed, but unfortunately yeah.
Yeah. All
Well,
right.
good. Anything else? I mean, anything we can
Joe,
bring to the
I
table?
think you should let everyone know that
Yeah.
if they want to go to the next step, they should get in touch with you. And
Please do.
if they want to see a one-on-one or quote one of their parts or whatever, we can do that for them as well. So,
Thanks, Jeff.
Yep, I can't think of anything else, Joe.
Yeah. No, if there's any questions outside of what we looked at today, if we want to talk say sales questions in regards to cost, please notify me. I'll be open to give any type of any questions you have or provide you any demonstration or costing.
Yep. All right. I just want to thank everybody. Thank you, Joe, for putting this together.
Yes, thank you, and thank everybody, and have a great day, everybody. And please feel free to give me a call if there's any questions.
Yep.
Great, thank you.
All
Thanks a
right,
lot, guys.
Take
Thank
care.
you.
Thank you.
Bye now.
Thanks.
Goodbye.